The second type of graph is the velocity varies time graph. First, write down the equation of each of the segments given in the graph. You might get a fit plug, and the equation might be given to you, which will save few steps. Now, if asked for the position time graph or asked for the distance traveled, you must integrate. If, for example, the equation only asks for this distance traveled and the graph is simple linear graph, you can calculate the area under the graph by adding up the rectangular and triangular space underneath the graph. If it is no linear graph, you have to take the integral equation. So for each position equation, you have to take the integral. Let's take a look at quick. Example, in this equation, we want to draw position. First time graph, the equation for each segment is V equal 12 over 30t, and V equal 12. Remember that the velocity, the derivative of position with respect to time. So you need to write the equation as ds equal v dt. Most of the time it will be, say, the object started from rest and your lower bounds for the integral will be 0. In this example, you can see that velocity is 0 meter per second at time value of second, which also means it started from displacement of 0 meter. So take the integral of the first segment. We get 12 over 60t square. Once you look in this integral, you need to find displacement at the time before the new segment starts. So looking at the graph, we see the new segment start at 30 seconds. Substitute 30 seconds in and we get a displacement value of 180 meters. So at 30 seconds, object move 180 meters. You need that at least pound of the next integral. Always remember that which you find the new distance time has, you need to change the lower bounds for both sides, distance and time. Then you take the integral for the next segment. You will now have two displacement equations. You can plot them as a new graph if it is asking for the distance travel in certain time. Simply substitute into the displacement equation and the value you get it is distance travel with that time. Remember to use the equation that corresponds to the correct time. So what I mean is, in this example, if the question asks how far you travel in 25 seconds, we need to use the first displacement equation because it is represent a displacement for 0 to 30 seconds. If ask the distance travel in 40 seconds, then we need to use the second displacement equation. Let's focus on acceleration. If the question asks for acceleration, you just take the derivative of your velocity equations because A equal dv over dt and you will get acceleration equations for each segment. In this example, we get 12 over 30 meters per square for the first segment and 0 meter per second square for the second segment. You can then plot those various time